Welcome to another video from explainingcomputers.com. This time we're going to use a Raspberry Pi Pico to help us build a digital rain gauge that'll let us know how much rain has fallen from the sky. And to do this we're going to construct a tipping bucket mechanism. And this has two little buckets on a sort of seesaw, and the way this works is that one of the buckets fills up with rain, it tips that way, the other bucket fills up, it tips that way, and it keeps on tipping, and we can use the Pico to measure those tips and to calculate how much rain has indeed fallen from the sky. And if all of this sounds very exciting, indeed it is, so let's go and get started. Right, here we have the Raspberry Pi Pico we're going to be using, which as you can see is currently mounted in a breadboard and hooked up to this 2-line 16-character LCD display, just as it was at the end of our last Raspberry Pi Pico project. And this is rather handy because it means we can output the amount of rainfall and time elapsed on this display, so I'm going to leave things as they are, I'm not going to reinvent the wheel. Now, as I mentioned in the introduction, we're going to build a tipping bucket rain gauge in which the Pico needs to monitor the movement of a seesaw. And to do this, we're going to be using a reed switch and a magnet. And in case you've not come across a reed switch before, over here I have a fairly large glass reed switch, and I've also got an old magnet from something or other. And if we cut into a close-up and I bring in the magnet, you can see when the magnet is close, the contacts close in the reed switch. It's almost like magic. I really do like reed switches. But in this project, we're not going to use this large glass reed switch, but rather this tiny plastic one and this very small little magnet. And this is because small plastic reed switches are cheaper and they're also far less easy to damage. And just to give you an idea, this is 14mm long and 3mm on its cross section, and this came in a pack of 10 with 10 tiny magnets for a total cost of £7.99 on Amazon Co UK. And an almost identical set from the same manufacturer costs $8.99 on Amazon.com. And of course I'll provide links in the video description. Anyway, back with the Pico, I've wired up a reed switch between GP0 and the 3.3 volt rail, and I've loaded onto the Pico the counter program from my Pico LCD module video. So if I turn on some power to the Pico like that, it says count equals 0, and I've taken this piece of plastic and mounted on the end of it one of these small magnets. So if we cut into a close-up and I bring in the magnet, here it is, let's turn it this way up and move it across the reed switch. 1, 2, 3, tipping bucket, tipping bucket, tipping bucket. This is the mechanism we're going to use in our rain gauge. And if you're wondering about the wiring and the code, over on explainingcomputers.com on the Raspberry Pi Pico LCD projects page, we can see the wiring for the LCD screen and for here a switch, although we've now got a reed switch in that position. And there are links here to all the code. Here is the code for the counter. And in fact, if I go across to Thonny, which is running here, this is the actual code running. Let's stop it with Control-C like that. And we can see up here, let's just give ourselves a bit more space like that. We basically import modules required for the LCD itself. We import time, we set up our switch, and then we set up some variables and have a very small while loop to run our counter. And we'll be able to alter this code to turn it into the code we need for the rain gauge. But before we do that, we need to construct our physical mechanism. Greetings! I've now been busy designing some 3D printable parts, which include a little tipping bucket, as well as a bracket on which it will be mounted. And we'll also have a funnel on the top to capture the rain and to direct it in the right place. And then there are a housing and outer brackets that'll hold everything to a baseboard. And for the sides, I'm going to be cutting out some clear plastic sheet so we can observe things in operation. And I'm going to be sharing everything on Thingiverse, including an alternative housing with solid sides, which some people might find useful. Anyway, right now I don't know if all this is going to work, so I printed just the little bucket here it is, and also the bracket, and it goes in it something like that. And this will work with a bit of axle. This is 2mm brass. And so I think what we should do is to put these together and conduct an experiment, which by the magic of filmmaking is now set up over here. So I need to pour the water in just the right place. It works. It works. I do like computing that physical mechanisms at work, especially first time, are even more exciting, I think. So I've now got confidence to build the other parts for the rain gauge. And there we are. More 3D printing is now taking place. In fact, it has taken place. By the magic of filmmaking, I've now got all the 3D printed parts. And they include the funnel, which is my favourite part, I think. This has got an exact 100mm by 100mm top, which will make calculations easier in a few minutes' time. And this will bolt on top of this piece here, which is the sort of the housing. And the housing sides will be made out of perspex, as I mentioned earlier. Here's some little bits of perspex, and you see those on camera? Oh, they're shiny, like, oh, shiny, shiny. And these bits go on like this. They'll go on with our friend glue. Glue will hold those in place. And you might be looking at this thinking, they're the wrong size. If I take a bracket like this, which will bolt this thing down to a baseboard, you can probably see there is a gap under here, but there has to be a gap under here to allow the water to escape from the tipping buckets. If this went down to the bottom, the whole thing would fill with water. So this is the water escape gap. And in addition to these parts, we'll also need some nuts and bolts. Here they are in a little box so they don't escape. And with everything now prepared, I think it has to be time for some construction. And here we go, construction is now complete. I've put the top piece together. I've also put the tipping bucket into the bracket, mounted the reed switch and the magnet, connected it up with a load of wire. It's about 4 meters of wire between the sensor here and the Pico, and that of course will allow the Pico to be inside and the sensor unit outside. And if we watch the counter here and I move the bucket, yes, it is still working. If I give you a close-up, you can see more clearly how the magnet moves across the reed switch, and the design here allowed the reed switch to be positioned in exactly the right place. It's in the slot where you can move it up and down, back and forth to get it well in the right position. And it's also worth noting we've got a couple of washers on the axle on either side of the bucket. And so I think it's now time to bolt the top section onto the baseboard. There we go. That's also now done. And it's getting difficult to show you this, but if I just try and just tip that like that and tip it like that, it's still working. You can see the countdown there. It is tipping and tipping. However, we don't really want to know how many times the bucket tips in this. We want to know how much rain has fallen into the funnel. And so we now need to get on with that. Now, as you may recall, the aperture at the top of our funnel is 100mm square, and so 100mm of rain entering the funnel would be a 100mm cube, which has a volume of 1 million cubic millimeters, or in other words, 1 litre. Therefore, if we pour 1 litre of water through the rain gauge, we know the resultant count of bucket tips will equate to 100mm of rain. And guess what? Earlier, I did exactly this, pouring 2 half-litre jugs of water through the rain gauge. And this resulted in 132 tips. So, we know that each bucket tip equates to 100 divided by 132mm of rain. Or, in other words, the resolution is about 3/4 of a millimetre, and if you wanted a finer resolution, you could adapt the design with a bigger funnel. Anyway, taking this information, I've prepared some code, and I've also switched to a darker theme with a larger font here inside it so we can see things a bit easier. And just to run through what's going on, first of all, we're importing our modules and setting things up. And I would note that the LCD module needs to be installed on the Pico as covered in my previous Pico LCD video. We're also again importing pins so we can work with a GPIO pin, and we're importing time, and we're clearing our LCD display. After that, we're going to set up our reed switch on the GP0 as previously with an internal pull-down resistor. That does that. And then after that, we've got various starting off things. We're recording the start time. The Pico does have a real-time clock, and time.time will report the time beyond the epoch, which we'll use as our start time here. And we're also setting a value tips to 0. That's obviously could be our number of tips. And we're printing a couple of words on the screen, which are going to stay there. Rainfall on the top line and in on the second. Then after that, we've got a while loop, which is going to make things happen. While true will always be true, so this will run indefinitely. And what this code does is to display elapsed time as well as rainfall. And so, as you can see, we work out hours by taking start from time.time, which is the current time, and dividing by 3,600, the number of seconds in an hour, and then making that an integer. And then we also work out minutes, which is a similar thing but dividing by 60 because there's only 60 seconds in a minute, and taking off hours times 60, so minutes will always be in the range 0 to 59. And we're working these things out here so we can create a string which we can pass across to the LCD for printout. And this string is created here, elapsed equals the format you can see there. It's going to pick up hours and minutes, and it's going to format minutes, so it always displays as 2 characters. The 0 here shows it'll use 0 to prepend if it's not going to be 2 digits from the minute, and the 2 forces it to be 2 digits. And I note what's going on here in terms of our time display is we're going to end up with a system that displays hours which go well beyond 24. The hours can go on indefinitely, certainly up to 999 will fit on the display, and then it'll display minutes after that. So this is not a normal display of days, hours and minutes, it is hours with minutes on the end of that. And then moving on, we get to rainfall. We're going to calculate rainfall based on 132 tips being for 100 millimeters of rain, which means that rainfall is going to be tips times 100 over 132. And yes, you could put 132 as a variable somewhere else and refer to that variable. And if you are building your own rain gauge using a different size funnel, or indeed even building exactly the same parts and you want to accurately calibrate it, you'll need to replace this 132 value with whatever works for your rain gauge. And then guess what? We now create another string for our LCD, this one to report the rainfall in millimeters, which is going to be formatted with 1 decimal point as a floating point variable. And then finally, we print these things to the LCD display at the appropriate coordinates. And then moving on, we have to check if the read switch has been closed, if the magnet has passed by it. So we have another while loop. This is while switch value, which will be true when the switch is closed. If the switch is closed, tips is tips plus 1, but we don't know how long it'll take the magnet to go past the read switch, so we have to make sure that we don't continue until the read switch has been released. So again, we look to see if the switch value is true. If it is true, we have a little loop, goes on till it isn't true, and continues in the main loop, which has a tiny pause at the end just to keep things happy. And there we are, this is our code. And so all we have to do now is to save this to the Pico so it'll auto run. So we'll do a save as, select the Pico, and we have to save as main.py to auto execute on the Pico. So we will do that. Do we want to overwrite it? Yes, we do. And I think we should now conduct a final test, which by the magic of filmmaking is all set up. And I'm just going to pour a small amount of water into the funnel. And yes, who'd have guessed we have a working rain gauge, which is now ready to brave the elements in a real-world experiment. Greetings, and guess what? It is now raining. And inside we've got the Pico monitoring the rainfall. No rainfall registered yet, but who knows, it's early days, because outside the rain gauge is there, in the rain, being rained on. As you can see, the baseboard is sandwiched between bricks on either side to hold it all down, keep it off the floor, so that hopefully will be okay, even if it's a massive storm. And I was very, very positive about this when I started, and I'm going, oh, is it really going to work? Is water going to go down the funnel and make the thing actually tip? But it may. It's due to rain in Nottingham for the next 12 hours or so. It's raining quite heavily right now, so we'll continue with this experiment and see how much rain we can record. And here I am back again. It's still raining down onto the rain gauge. And if we look inside on the display, we can see we've had 9.1 millimeters of rain in the past 2 hours, 35 minutes. And given that heavy rain was forecast for Nottingham, we were expected to have something like 30 to 50 millimeters of rain in the 24-hour period. This seems perfectly reasonable. It's been raining pretty heavily most of the past 2.5 hours. I can believe we've had 9.1 millimeters of rain. So I think this system is working. I'm very pleased with the result. And what I'm now going to do is to leave this system running overnight. It's currently about 4:30 in the afternoon, so I'm going to leave this till tomorrow morning, and then we'll check on progress with the rain gauge. And here I am back again. It's now the next day, and it's dry as we can see. And in fact, shortly after I spoke to you on the second occasion yesterday, it stopped raining, and it hasn't rained since. And so if we look on the display inside, we can see that whilst time continues to progress, we've had no more measured rainfall. And the fact that time is still advancing, we've been running at Pico nearly 25 hours now, means the Pico is still obviously working fine, although I would like to check the rain gauge sensor is still operational. And so what I'm going to do is to grab Mr. Hosepipe, and there we are. The rain gauge is still clearly fully operational. Over the years on this channel, I've built several Raspberry Pi weather measurement projects. And so far, my favourite has been the anemometer, which I built to measure the speed of the wind. But I do think that now probably my favourite is the rain gauge. I've been very pleased with this project, and I hope it's given you some interesting ideas to use in your own Pico projects. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.